So cloud computing, cloud, and I have a t-shirt that says there is no cloud. It's just somebody else's computer. Well, literally, that's right. There isn't a cloud.
Big backup computer, yeah.
Yeah, it's just somebody else's computer you're putting stuff on, but it really is a model. So you have access to a shared pool of available resources. You don't have to provide the infrastructure. All you have to provide is the internet access. Well, then what happens when your internet access goes down?
You don't have access to.
Yeah, you got no access.
Unless you got local saves, but
You have what?
unless you have local saves, because it does locally save in that area. For a little bit, yeah.
Offline.
I've been able to access stuff on my OneDrive.
I know that Apple.
Oh, okay. If you have the OneDrive app synchronizing to your computer, but if you're writing completely on the web browser, you're out
Oh,
of luck.
no, there you go.
Yeah, you're out of luck. What'd you say, Dylan?
Oh, I know Apple really tries to shove the backing up on cloud
Mhm.
down everyone's throats.
Well, it's a good idea.
It's
Yes,
good.
it is.
That is applications, but
It is one of the the 1, 2, 3 rule of backup. One of the rules is have something off-site, and cloud computing is off-site. But is it your only place you should put your eggs in?
no.
But it's really hard to have local backups of some of the stuff. I mean, how would you have a local backup of Blackboard? You couldn't. But Blackboard, I think, does its own or something, because that Blackboard never went down. It was working fine. Some of our stuff wasn't working fine to get to it, but when you look at having to do it all yourself, and you look at the cloud computing, there are less single points of failure for Amazon Web Services than there are for hosting your own. You have experts running it, that's all they do every day. And in a small business in a small town like this, you can't afford experts because nobody wants to live in Scottsbluff. Unless you have family here or somehow have ties to the area. I learned that 50 years ago, working with some businesses. So elasticity, what does elasticity mean as far as cloud computing? Elasticity,
You have a lot more range,
range for what?
like of either storage. Yeah, probably storage is probably the best one there, because then if you don't, you only use what you need.
Yeah.
So,
That's exactly right. So that's an example. If you suddenly need a whole bunch more file space, they can automatically expand for that. So it's elastic. Another example is Amazon. Right now, they're under normal load. What do you suppose happens on Black Friday? Kabow!
Yeah.
Or Christmas, they have to be, it has to be able to be elastic. If we have our own local server thing, how do we be elastic? Well, you have to buy new servers that then sit idle all half the year. So scalability is part of elasticity. They can ramp things up much more quickly than you can on a local. And that's the other part, pay per use. You pay for what you consume. And it's on demand. Is it resilient? Well, most of the time it is.
usually,
Yeah, it usually is, but I think Nicole was saying that it's been like 3 years since they had their last outage, it was only for a few hours. But this is just the one that got in the papers or the news. So yeah, we know how that works. Here's your cloud vendor with all this cloudy stuff out here. And we connect to it and hopefully our internet keeps going. So what on this page looks like single points of failure?
the internet.
How could you not mitigate that? How could you, make that redundant? How could you make internet access? How could you redundify it? I'm not finding the right words. But how could you relieve that single point of failure?
More routers maybe?
Yeah.
More routers, yeah.
You could, I guess, use a hotspot technically, even though it's not.
Okay, what else? More routers, hotspot.
You can also keep everything on site, and then you don't have to go out to the internet.
Yeah. The almost all, small business routers like the one I have, the Fortinet, almost all of them have 2 WAN ports. So what does that mean?
Oh, I mean, you could just use one of them. Or having both plugged in even.
Yep, I could use Allo, I could use Charter. Allo goes offline, Charter takes over, except how it works is they load balance. And if this one goes off, this one keeps going.
I didn't do that.
Yeah, it's built into it. I just have no reason to use it.
I've only ever.
I would have, I don't know, I'll have to ask Jason if. The hospital is much more critical than we are. If things go off for a couple hours, nobody's gonna die. At the hospital, that's a whole different story. People could die if things don't work. So they may have redundant internet. I don't know. I have to ask Jason that the next time I see him. Not necessarily. It's a cost thing, you know, the minute
Good
you,
idea, but.
it is a good idea, but you're paying twice as much now.
Yeah,
And you can only, how much redundancy can you afford? That's where it comes down to, because you don't have unlimited money. You know, you don't have unlimited resources, so you have to, you know, do the balancing act. And yes, when the hospitals, this is like 30, 40 years ago, the hospitals put in a fiber ring around all the hospitals in the panhandle. One of the things they did is they put in 2 rings, 2 redundant rings. Every hospital had 2 redundant routers, 2 redundant everything. So they made it very highly available. You suppose that costs twice as much? Not exactly, but it costs a lot more than if they just did one, but they're hospitals.
yeah,
So they needed that redundancy. And that's how they all get internet access, is through that. And probably that, the redundancy for internet access comes from that ring getting its own redundant internet access. And Regional West is kind of like the hub of the whole thing, you know, as it's moving around the panhandle. All right, well, we already did that. Well, we know what a public cloud is. A community cloud, we've not really done. We kind of, hybrid cloud is what a lot of people do, and do we have really a hybrid? Do we have a public cloud, private cloud here? It depends on how you look at it. Everything we do through our, I'm trying to think, we don't even have anything. Oh, for instance, authentication. We have a local copy of Active Directory, which authenticates all the students, plus it's replicated in the cloud. So that's kind of like a redundancy there to some extent. They moved the authentication, not moved it, but copied it to the cloud, because if our internet goes down, if I'm in Timbuktu, I still can't get to Blackboard because I can't authenticate. And that happened for 3 days once. Nothing would happen just because we lost our internet for 3 days before they finally found out it was a failed fiber something. May have been a failed fiber splice or something that they discovered. Because it was really hard to figure out the issue. Allo would say it's us, we'd say it's Allo, and you know, it's Network Nebraska, and you know, it's really hard to troubleshoot that sort of thing. All right, okay, computing central lab, whatever. So, oh, yeah, we'll move on to there. Yeah, do we need to know this? Sure, cloud models. Software as a service. So our Blackboard is software as a service. We do nothing with Blackboard. We just log in, we have administrators that work with it. We have nothing that runs any bit of it. We don't do anything to it. They do everything for us. Platform as a service, which I don't see as often. I mean, because mostly I worked with little businesses. That means that, oh, actually, one of my students in Python, he's using Oracle as a platform, and then he does all the applications on that network, and he's using Oracle, which I didn't know they had a free tier. Infrastructure is really interesting as a service. You can like deploy and run your own software. Well, what did we do in server class that was like that? We installed our own servers on Azure. So that would be like infrastructure as a service. And then anything as a service is kind of a new one. It just means anything that has to do with cloud computing. I don't know. Many people use software as a service because it's a turnkey solution. You don't have to do anything. They take care of it. Like Blackboard takes care of Blackboard. They're the experts in it. So that's what we want, is them to take care of it. And that's one advantage of cloud computing, is the people that do this, that's all they do every day, 24/7. They have the support and everything else. But things can go wrong, you know? So this is a typical infrastructure. You're gonna have your web servers at the front. They take the request, and then that goes to the application server. So this is kind of like MVC, like we talked about in computer science, model view controller. So this is the view, the part where you see things and click on buttons. This is the controller where it says, okay, well, let's put a record into the database. Let's delete a record. Let's show a record and do some filtering. This does the business logic that fetches things from the database and then shows it to someone in the view. So lots of things in IT are done in layers. That means that the people working on the web servers, they can concentrate on just that and that's it. Same thing here. They can concentrate on their little piece. They can concentrate on their piece. They don't have to know the whole stack. That's what that's called. It's a stack because you've got, you know, all those things going on. Okay. Cloud, whatever, microservices. Okay, we don't need a knowledge check. Okay, that's getting a little further than I want to go. So, yes, my sister does. She doesn't do security audits, but she does OSHA audits or safety audits. If you don't audit things every so often, you don't know what's going on. So we, as a college, have a company that does security audits. And so we get a report every year that says, oh, you're doing this. Oh, you should be doing this. Oh, you're doing this. Okay. You know, that sort of thing. So the things they say are okay and that you can improve on, that's where they focus their resources, is improving those things. And so audits are an important part. Okay, so we'll move on. Yeah. Okay, encrypt. There we go. So, and it's just not hybrid clouds. Almost everything encrypts everything between everything. When was the last time you went to a website that wasn't encrypted? Email is all encrypted. Email is encrypted from server to server. We have almost point-to-point, end-to-end encryption everywhere. In this room, yeah, everything's encrypted. Because the website you go to, if you talk to the server, it's all encrypted. There are some things like DHCP and DNS and some of that other stuff that internally we don't have encrypted. So you want to monitor, you want to look at things. Automation, yes, automation means you have to spend a bunch of money. But if I had to look through 85 servers and look at each event log and to see what's going on, or I could have a service that goes to each of those event logs, pulls out the appropriate things I should be looking at and gives me ideas of what I should do to fix it. Yes, I'm going to pay for that because I can't do it otherwise. There's just not enough time. And regular scans to identify weak points would be like, kind of like a internal penetration testing, you know, like you see if somebody's out of date, see if somebody's antivirus isn't working right. Securing all endpoints. So the rule that people use now in cybersecurity is zero trust. You don't trust anything, and then you allow what you need, which has always been the paradigm for firewalls for years. Don't allow anything, then just allow what you have to have. Rather than at home on your firewall, everything's allowed. But that's a different situation. What is the word? I think Ronald Reagan said, trust but verify, or something like that. I don't remember. So we know what virtualization is. We shouldn't have any trouble with that concept. We use that in about every class I have. And how much virtualization do you suppose is used in the cloud computing?
Almost all.
Probably all of it. I mean, a large amount of it, because it's so much easier to migrate a virtual machine from one machine to another. I mean, if I do that back here, I just have to copy it from one to another and I'm done. You can also do what's called a hot migration, which means that you can keep the system up while you're migrating it to another computer, which is interesting. So there's two types of hypervisors. Hyper-V, which I have running on my server, runs directly on do they have a picture? Oh yeah, here we are. So this is what I have in my servers. I have the hardware. I have Hyper-V, which the server Hyper-V is different than the Windows Hyper-V. This runs right on the hardware. And then I have Windows 2020, 2025. And then on top of that, I have Minecraft or Internet Information Services or whatever. I only have three things to go through. When we're running VirtualBox, that runs on top of the host OS. So we have one more layer of abstraction is what it's called, but it's one more layer of performance hit, so to speak. But I don't know if anybody that uses VirtualBox for production, unless it's very small, It's mostly used for training, and if you need more than one OS or you're doing tech support and you need to help somebody walk through some particular system, it's used a lot for that. All right, a container. All right. So a container, I'm thinking is something like, basically it's an application and I can't, Docker is an example. Docker has like the whole application inside it. And then you can move it from one place to the next without having to reinstall and do all that stuff. Well, it's easier said than done. I've tried to use Docker a few times and it's more complicated than I want to do. So we tried here to do virtual desktop infrastructure, but it didn't work because we're using Microsoft's product, which just wasn't ready yet. What that means is that I could log on from here and then I could log on from home. I could log on from Barcelona. I'd have exactly the same desktop. I would have access to all my files no matter where I am. So ideally, that's a good situation for a college because we're always in bunches of different places. Well, it didn't work. The hardware cost was too great and it just didn't work right. It was very slow, and so they pulled the plug on it. VMware is the king of that sort of thing, but we couldn't afford it. That's just way too much money. And NVIDIA, because you're running a desktop on a server, you have to have a good NVIDIA graphics card on it, and that costs money, and their licensing was ridiculous. So there's lots of reasons that it didn't work. But that's what a container looks like. And Docker is an example that I've never quite figured out how to use that yet. And then I come into other projects I need to do ahead of time and grade papers and teach classes, and it just gets in the way of my playing with toys. So you know how that goes. There we go. Now we don't need to do that. Now we don't need to worry about that at this point. Security concerns, you can test updates. So if you're a company like Amazon, before you update your store, you know, the Amazon store, wouldn't you try it on some virtual machines before you rolled it in production? Yeah,
So,
yeah. That's what they did at Cabela's. I wish they were still here. We could go down and visit them every year. We did that probably 10, 15 years ago. We went down there and we'd go down every so often because they had like the enterprise system in the Panhandle at the time. And so one time we went to their software department. Well, they had literally test servers that the development team worked on. And then when they had that all fixed up, then they'd roll it in production. So they had a front end team. They had a middleware team. They had a database team. They had a security team that just tested things. You know, so they had all that stuff broken out and they tested it for, did it work right? And for security bugs, because they did all their e-commerce and everything on site. I mean, in their production environment. And a virtual machine is perfect for that. You know, you can set up, I mean, in system admin, we set up our own Windows server with our workstations. Well, that's perfect. It's isolated from everything. You can do whatever you want. Okay, moving on. Okay, we don't need to care about that. Oh, here's a question. Which type of hypervisor runs directly on a computer's hardware? We just had that 5-10 minutes ago.
yeah.
I think it was 2, if I remember correctly, but I'm not certain.
Am I giving you the right look here, Andy?
Yeah.
Okay. 2 is the one like VirtualBox. 1 is the one that runs directly on the hardware, type 1. I don't know what type 3 and type 4 are. I don't know if there is. I just threw that in there. I mean, type 1 and type 2 is what we don't really refer to it as that. Usually you'll think of it as like a server based one where it runs on the metal, you know, it's right off the hardware, where the other type runs off the operating system. I don't know what the common term is. Okay, we did our self-assessment, we did everything. So is it important to understand cloud computing? Yeah, but it's hard to teach it in a class because then you have to like pay money for cloud stuff, and I don't know.